right. Today we're going to be taking a look at solving logarithmic equations. As we talked about yesterday, a logarithm is the inverse of an exponential function. So today we're going to go through it and I'm going to show you how to solve a logarithmic function. Besides maybe the first or second step, you should find these very straightforward, hopefully. So the first couple of steps may be something new, and then it'll end up just being a regular equation that you solve, or you do to one side, do to the other side, etc. So number one, log base 2 of 32 is equal to 3x. The first thing we want to do is put this in exponential form. So in exponential form, this is 2 to the 3x equals 32. So yesterday I showed you how to go from logarithmic form to exponential form, and then exponential form to logarithmic form. So step one, when you see these problems, put it in exponential form. Now from here, this turns into an exponential equation that we learned how to solve a few days ago. We need to make these be the same base. So if you have that chart with the numbers and stuff out, you may want to pull that out. So we need to make sure that we check to see if we can make them be the same base. I can change 32 to be a base of 2. 32 is 2 to the 5th power. So now that I have the same base, my bases cancel. We have an equation, 3x equals 5, and we know how to do this. Divide both sides by 3, and we get 5/3. So the answer to this first one is 5/3. And that's all there is to it. Let's definitely try a whole bunch more. So number 2, log base 4 of 5x plus 1 is equal to 2. This is in logarithmic form, so I need to change it and put it in exponential form. So in exponential form, this is 4 squared equals 5x plus 1. So just a reminder, when you're going from log to exponent, your base is still the same. My base is 4 here, so in exponential form, 4 must be my base. 2 is my base here, so in exponential form, 2 must be my base. 4 times 4 is 16 equals 5x plus 1. Subtract 1 from both sides, we get 15. And divide both sides by 5, we get 3. So the answer to number 2 is 3. So as I stated at the beginning, besides maybe the first step, after that it just turns into solving a regular equation. All right, number 3 and 4. Number 3, log base x of 1,000 is equal to 3. Put it in exponential form. X to the 3rd equals 1,000. So we need to find the cube root of 1,000. So some number 3 times gives us 1,000. So some number times itself 3 times gives us 1,000. That number is 10. There's also a button on your calculator in Desmos as well, the cube root button. It looks kind of like this. So in the calculator, so it's not a square root. It'll have a little 3 on the outside, or you can insert the 3 on the outside. You can put 1,000 in the center of it, and then the cube root of 1,000, it'll give you that 10 is the answer. Now, the first 3 that we've done, there's only been one log on one side of the equation. So the rest of them that I'm going to show you are going to have a log on both sides of the equation. If you have a log on both sides of the equation, make sure your base is the same. So I got a base of 4, I got a base of 4. So I have a log on both sides. Those logs are going to cancel. Anytime in math you have the same thing on opposite sides, they are going to cancel. So log 4 cancels, log 4 cancels. So this gives me 3x minus 1 equals 2x plus 3. Then I go through and I solve this equation to get our final answer. So subtract 2x from both sides, add 1 to both sides, and voila, x is equal to 4. I got 2 more for us to take a look at. Number 5, they're both log 4s, so that's good. So they're going to cancel out. And we're left with x squared equals negative 6x minus 8. Now, this is a quadratic equation. We got lots of different ways to solve a quadratic equation from earlier in the semester. First thing we need to do is set this equal to 0, though. So I need to move everything on over to the other side of the equation. So x squared plus 6x plus 8 equals 0. So they were negative on the right hand side. Move them over by adding. Now I need a factor, so we'll set up our parentheses and we'll factor. two numbers that multiply to give me 8 and add to give me 6. Those numbers are 4 and 2. Then after you factor, you set your factors equal to 0. So x plus 4 equals 0 and x plus 2 equals 0. And you solve each one. We get negative 4 and we get negative 2. You definitely want to check your answers, just like a little earlier when we talked about, radical equations, how you want to check for extraneous solutions. You definitely want to check your answers. So you would take negative 4 and substitute it back in and see if you get the same thing. So if I take negative 4 squared, it's going to give me 16. Negative 4 is 24 minus 8, so I get 16 on both sides. And I would do the same thing over here. Negative 2 squared is 4. This is 12 minus 8, so both of these answers are going to work. So I did a little mental math check, but you do want to take negative 4 and negative 2, substitute them back in for your x's, and both sides should be a true statement. And the last one, number 6, they're both the same base, log base 10. And just a reminder, sometimes you might see log by itself. If you see log by itself, the understood base is 10. But for this particular problem, I did go ahead and write the 10s in. So this is going to give me x equals 5x minus 20. Go through and solve your equation. So, it doesn't really matter, but we can subtract x from both sides, add 20 to both sides, and divide. And voila, we got 5. So just one more thing, sometimes your answers may not work. So if you got a positive and a negative answer, you want to take the positive answer because logarithmic equations, our basic equation, can't be something that's negative. So again, just make sure you check your answers when you get down to the problems that have 2 solutions, because one of them will work and then one of them will not work. So you want to take the positive answer if you end up getting a positive and a negative answer. All right, now you're all set to go do today's assignment.